All right, AP Calculus, as promised, I'm going through test 8 with you. First question, which of the following statements is true about the function f of x equals x squared plus cos x? F of x equals x squared plus cos x. Look at the choices. They're all about symmetry, about various things, okay? This should immediately throw off in your brain that the topic we're talking about here is even, odd, neither. And that, in turn, should set off in your brain this kind of test. The test is always the same. Stick negative x into the f function. If f of negative x equals f of x, you're even. And if f of negative x equals negative f of x, you are odd. If you are even, you are symmetric about the y-axis. Think cosine of x. If you're odd, you're symmetric about the origin. Think of sine of x. So we're going to just run this thing. F of negative x equals negative x squared plus cosine of negative x. All right, let's keep going. What is negative x squared? That's x squared. What is cosine of negative x? Since cosine is an even function, cosine of negative x would be what? Cosine of x. All right, what do we now notice about this and the original function? They are the same. Do you see that? Therefore, the definition of even has been met, and if the definition is even has been met, you know you're symmetric about the y-axis. All right, therefore the answer should be A, symmetry about the y-axis. Question number 2 says, which of the following definite integrals is equivalent to this following function? All right, so let's write this out. Definite integral from x equals 0 to x equals pi over 8 of secant squared 2x e to the tangent of 2x dx. Now notice in the original problem, it doesn't say x equals 0 to x equals pi over 8, but I know that to be the case because this is an x dx. X dx, it all has to be the same. All right, now, what I notice is my choices are in u, which means I have to convert to u, which may give me a hint that I'm doing u substitution here. How can I prove to myself that that's even a possibility? Well, this is a composite function. The inner function, one way to look at the inner function is tangent of 2x, and the derivative of tangent of 2x is secant squared 2x times 2 using the chain rule. That's the rest of the integram. This is a classic u substitution. So u is equal to tangent of 2x, therefore du dx is equal to secant squared of 2x times 2. Chain rule. Chain rule is a ubiquitous thing on the AP exam. You always got to be aware of it. It's always going to be there. Great. Therefore, we want to get rid of secant squared 2x dx. We don't want this 2 over here, so this is going to become 1 half du is going to equal secant squared 2x dx. All right, we have all the ingredients we need. Let's start with the integrand. Secant squared 2x dx is 1 half du. E to the tangent of 2x is e to the u. Now, some of you got this far, but then had an error. You didn't convert everything to u. These are x limits of integration. They have to become u limits of integration. How do you convert x equals 0 to u equals something? How do you convert x equals pi over 8 to u equals pi over 8? The u substitution equation that you first developed will give you the answer. Look, this is a function u of x. X goes in, u comes out. So x goes in, u will come out. If I plug in 0 here, I get tangent of 0, which is 0. If I plug in pi over 8, I get tangent of pi over 4, which is 1. Now, I look for this as a choice, and it looks like I find this choice to be C. 1 half, 0 to 1, e to the u, du. Okay, that's C. All right, question number 3. says find the minimum value of a function f on the interval, closed interval, from 3/2 to 5. Technically then, this is a absolute minimum problem, and I should use the absolute minimum test. Well, that's one way to approach this. So, anytime you find a minimum, I don't care if you use first derivative test, second derivative test, or absolute minimum test, you got to find locations of possible absolute extrema, which only happen at critical numbers. How do you find critical numbers? You take your function that you're trying to maximize or minimize, and you take its derivative and set the derivative equal to 0 or dne. Okay, now you set this thing equal to 0, and you hope that this factors. Does it factor? The answer is yes, it does. It factors into 0 equals 3x minus 4x plus 2. See it? 3x squared minus 4x plus 6x. That should be minus, sorry. 3x squared minus 4x minus 6x negative 10x plus 8. Okay, therefore x is going to equal 4/3, and x is going to equal 2. These are critical numbers. In the absolute extrema test, we wind up testing f directly. We don't have to set up a sign chart, we just need to test f directly at our various values. Okay, what were my endpoints that were given in this problem? I have to ask myself. The answers are 3/2 and 5. So 3/2, that's an endpoint. I've got a critical number at 4/3. I've got a critical number at 2 and an endpoint at 5. And now I would plug each of these values in to the original function f in order to find out what they are. That seems like a lot of work, and it is. I believe the minimum is going to occur here at 2. But let's think about this, think this through, see if there's a way to reduce things. I know this thing fundamentally looks like x cubed, which I know probably if it's got any sort of humps, it's going to look something like this. Okay? So where could we have, we're looking for, again, a minimum value. We could have a min here. Okay? And then let's say there's 2 endpoints. So here's an endpoint, and here's an endpoint. All right, one there. One there. You have this other critical number. You have a local min here. You might have an absolute min here. That would equate to this number right here on our list from left to right. The other place you could have a min would be over here. Definitely not up here, right? The other place you have is the first number. So really, these are the only 2 you actually have to check if you know what the graph looks like. Let's try 2. That's 2, 4, 8, 16. 8 plus 16 is 24. 2 squared is 20 minus 20, that's 4. Sorry, that's 4. Okay, you can check 3/2, but you're going to see that it's bigger than 4. So that's our answer. The minimum value is 4. Where does it occur at 2? What is it? It is 4. Therefore, the answer should be B. B. Now, let me show you something. In Mrs. K's little grading here, notice what she didn't do. She didn't actually use the absolute extrema test. What test did she use? She just used the first derivative test. She tested only the 2 critical numbers, and she tested the left and right to see where the mins and the maxes were. In her mind, then, the choices in the endpoints were not good choices. All right. And that has to do with your intuition about the shape of the graph. In my case, I said it's pretty clear that we only have to look at possibly this one or this one as our minimums. Great. If you do not feel comfortable making those kind of judgments, you just go through the tedious process of writing out all these values. Number 4, we're told, is the slope of the tangent to the graph y equals arc sine of x squared plus 2 at x equals 1 is. Slope is the graphical term for derivative, so you need to find the derivative of this function. So the function given is y is equal to arc sine of x squared over 2 at x equals 1. So find y prime. The derivative of arcsine is 1 over the square roots of 1 minus usually x squared. But in this case, it's composite function. The outer function is arcsine. The inner function is this 1/2 x squared. So I got x squared over 2, chain rule, times the derivative of the inner, which is 2x over 2. That's the same as what? X. All right. So I've got effectively y prime is equal to x over square roots of 1 minus x squared is x to the 4th. 2 squared is 4. Good. And now I'm asked to find the slope at x equals 1. So I plug in 1 here, and I get 1 over square roots of 1 minus 1 to the 4th is 1/4. So this is the square roots of 1 over square roots of 3/4. Sorry, 1 over the square roots of 3/4, which is the same as 1 over square roots of 3 over 2. It's the same as 2 over the square roots of 3. And that should be your answer. 4 is 2 over the square roots of 3. Yes. All right, that's number 4. Notice twice chain rule came up. Chain rule came up here in problem 2. Chain rule came up right here in problem 4. And that's how it's going to be in the AP exam. You just got to be aware that composite functions require chain rule. We go on to question number 5. Question number 5 says, for every function, justify that it's even, odd, or neither. Okay. Same thing as we did in problem 1. Y is equal to x to the 4th minus 6x squared plus x. How do you test even, odd, or neither? You plug in negative x. All right, so this is negative x, the whole thing to the 4th, minus 6 times negative x squared plus negative x. Look at my judicious use of parentheses. I don't want to mess this up. Negative x to the 4th is x to the 4th. Negative x squared is x squared, so it's just minus 6x squared. Negative x. I see, does this match up with the original? Yes, yes, no. So this does not equal the original y. Does it equal negative y? No, not at all. Well, if y doesn't equal y, y of negative x doesn't equal y, and it doesn't equal negative y, then the answer should be neither. The answer for 5a should be neither. All right, 5b has us looking at another function. Y is equal to x tangent of x. Very good. So let's plug and chug. Y of negative x equals negative x tangent of negative x. I need to know here that tangent is odd. It always will be odd. So, by that definition, tangent of negative x is negative tangent of x. The negative cancels with this negative, and you're left with x tangent of x, which is the same as the original function. So if y of negative x equals y, then the function must be even. All right, question number 6 says, integrate over y to find the area completely enclosed by the graphs of x equals y, 3 minus y squared, and y equals 1/2 x. And you must sketch for full credit. Great. This here is a sideways parabola, shifted to the right by 3, facing this way because of the negative sign. Okay, that right there should be the ordered pair 3, 0. And then we're told that y equals 1/2 x is a thing. It's y equals 1/2 x. This was x is equal to 3 minus y squared. By the way, if I wanted to write this in terms of x, it would be x is equal to 2y, right? Notice here is the region that's being enclosed. And I got to get its area. To get the area fully closed by this, I have to do this in y. Why not x? Because look, if I look at this chunk, it's top minus bottom, no problem. Right here, top minus bottom, no problem. What about right here? It's top minus bottom, But it's certainly not that same top minus the same bottom. Now it's a new top minus a bottom. And look, you have to break this up into a positive and negative form. So you're going to need two integrals, and you're going to have to think on this part of the integral. That's not ideal, so you want to use y dy. That's a good hint, you want y dy. So what we're going to do in our minds is we have this subrectangle. Everything in these integrals are subrectangles. You say, what's the length of this thing? It's always right minus left. Right minus left. So the area is equal to definite integral from y equals something to y equals something of the right function, call it x sub 1, minus the left function, call it x sub 2. So it's always right minus left in the y direction, and then of course it's going to be dy. Right? Now, we're going to go from y equals what to y equals what? Y and y. These are y values. You have to go from this y value, whatever it comports to, up to this y value, whatever it comports to. Well, how are you going to figure out where these y values are? You're going to set x1 equal to x2 and solve for y. All right, so we got x1 equals x2, or 3 minus y squared is equal to 2y. Well, this looks like it's going to be quadratic, so this becomes y squared plus 2y minus 3 equals 0, which then we hope will factor. Okay, so we get y minus 1, y plus 3 equals 0. Is that true? Y squared plus 2y minus 3. That works. So you get y is equaling to 1 and negative 3. That means that's negative 3, and that's 1. That seems right to me. So I come back here, and I'm going to go from negative 3 up to 1. Now, of course, I want to write this all in terms of y dy. So I'm going to write this as y equals negative 3 to y equals 1. Now remember, this is right minus left. The right function is this one, 3 minus y squared, minus the left function, x2, which is 2y. And I should put all of that in parentheses and dy it. This is correct writing. Great. Now I have to antidifferentiate and solve. Well, that's going to be great. So I antidifferentiate 3, and I get 3y. I antidifferentiate minus y squared, I get minus 1/3 y cubed. And I antidifferentiate 2y, and I get y squared. I'm going to evaluate this from y equals negative 3 to y equals 1. First part of the fundamental theorem of calculus. In the interest of time, I'm going to look at the key here and just find out the answer. So when we do all this, it looks like we get out to 32/3. 32/3, and my units are units squared, because I'm talking about area, a two-dimensional shaded surface. Yes. So, we continue. Number 7. Number 7 says integrate definite integral of 3x sine of x. I say to myself, there's no simple rule. Maybe it's use substitution. Nope, there's no composite function here that I'm going to get the inner function's derivative as being in there. So it must be the only other thing you know, which is integration by parts. That's right. So definite integral of 3x sine of x dx. Okay, you know how this works. You start with a u and you start with a dv. Okay, I think either way is going to work here. Let's go u equals 3x. dv is going to equal sine of x dx. All right? Remember, this is like something called u dv, and I've got to use up all the parts. I'm going to use this for u and that for dv. I'm going to differentiate here with respect to x. I get du dx equals 3, or du is equal to 3 dx. Got my u, got my du, already have my dv. Now let's bring the dx down. I get dv dx equals sine of x. This tells me if I'm going to antidifferentiate with respect to x, and I'll get the function v equals negative cosine of x. I have all my ingredients, because remember how this works? You can rewrite this as uv minus integral of v du. Well, that's that ultraviolet voodoo thing, which I still hate saying, so maybe I won't say it anymore. U is equal to 3x b is equal to negative cosine of x minus v is equal to negative cosine of x, and then du is equal to 3 dx. All right, well, let's clean this up a little bit. This is negative 3x cosine of x plus 3 times cosine of x dx, which equals negative 3x cosine of x plus 3 sine of x. It's an indefinite integral, so I must say plus c. And that should be my answer. Let's just check it. Number 7. Key says negative 3 cosine of x plus sine. Yep, that's exactly right. All right, so that was number 7. We're on to number 8. Number 8 says, an inverted canonical container has a diameter of 42 inches and a depth of 15 inches. If water is flowing out of the vertex of the container at a rate of 35 pi cubic inches per second, how fast is the depth of the water dropping when the height is 5 inches? Great. So inverted cone looks like this. Cones have heights. They have like that radii at the top. Okay, and they have things like volume and surface area. An inverted canonical container has a diameter of 42 inches. If the diameter is 42 inches, then the radius must be 21 inches. And it has a depth of 15 inches. So that means the depth of this cone is 15 inches. If water is flowing out of the vertex, that's out of the bottom. Okay, now think about water flowing out of the bottom. What is that? That's the rate of change of what? Water with respect to time? Yeah, we don't ever say it's rate of change of the volume of a water with respect to time. So dV/dt, how much water is passing is volume with respect to time. Water is flowing out of the vertex container at a rate of 35 pi inches cubed per second. Right. Rate of change of volume with respect to time. The units give it away. How fast is the depth of the water dropping? So we're talking about depth of the water. You call it height, you could call it depth. I'm going to call it height just because it seems to me better than calling it dd. When the height is 5 inches. That's another good reason to call it height. Okay. And the unit for h will be inches, because that's one-dimensional. Over time, that's seconds. See? I write the known rate, the unknown rate I'm solving for, and I got my picture. Now, immediately I'm thinking to myself, I've got to relate volume and height. Is there anything here that a known formula rates volume and height? Sure. This is a volume of a cone, 1/3 pi r squared h. It's got the h in there, it's got the b in there, it's perfect if I ddt both sides. Except I've got this radius in there, maybe I don't want the radius. So it would really help if I had some sort of relationship that would enable me to get rid of the radius. Well, here's a relationship. They're called proportional triangles. 21 is to 15 as, now think about this, the water isn't always at the same level as the tank, right? So when it's down here, that's kind of the water's height and radius, if you want to look at it that way. So 21 is to 15 as the radius is to the height. Oh, good. Now I can get rid of radius by solving for radius in terms of height. Radius is going to equal, what is that, 7/5 height. Yes. Okay. So I'm going to come over here to this formula and rewrite it as volume is equal to 1/3 pi times 7/5 height squared times height. Which I could rewrite again as volume is equal to 1/3 pi, 7/5 becomes 49/25. This is h squared times h, which is h cubed, which again I can write as v is equal to 49 over 75, 49 pi over 75 h cubed. Now I've just got it one simple variable as an input and one simple variable as an output. I'm going to ddt both sides. Let's ddt the left. And I'm going to DDT the right. Okay, what's DDT of V? dV dt. What's DDT of this mess? Well, the 49 pi over 75, you could pull out, because you could always pull that outside of a derivative or any limit. And then you just get 3h squared dH dt. You're using the dH dt, it's implicit differentiation at this point. Okay, 3 over 75 is the same as 25, so now we're back to dV dt is equal to 49 pi over 25 h squared dH dt. What do we ask to solve for? dH dt. Do we know the rest of the information? We absolutely do. dV dt, we're told, is 35 pi. We're told that h, when we're going to find out this rate of change, is 5 inches. Okay, so this is 5 squared, or 25, dH dt. Okay, 25 divided 25, that's going to go away. And so you're going to wind up with 35 divided by 49 is equal to dH dt. What will my units be? Exactly what I told you with the be fun. Inches per second. This is 35 over 49 inches per second. That's how we should write it. Okay, now we check that answer. Number 8 here says they got 5/7. So if you divide by 7, you get 5/7. Same thing. Great. So let's go on to number 9. Number 9 says integrate. Integrate. Well, immediately I'm saying to myself, I don't know any simple rule for this. And then I say to myself, maybe U substitution? Let me see. There's a composite function on the bottom. What if I just took this inner function? Oh, that's that guy's derivative scaled up. Yeah, it's definitely U substitution. So let me rewrite it. 9 is equal to the definite integral of 9 sine of 3x over square roots of 9 minus cosine of 3x dx. I'm going to set u equal to the inner part of this composite. U equal to the inner part of the composite function, which is 9 minus cosine of 3x. Therefore, du dx is going to equal, derivative of cosine is negative sine, so this is sine of 3x times the derivative of the inner, which is 3. Once again, that's another time the chain rule showed up. Chain rule shows up all the time. Always be aware of it when you have a composite function. All right, we don't want 3 sine of x dx. We're going to want 9 sine of 3x dx. So I need to multiply this by 3. So I'm going to get 3 du is equal to 9 sine of 3x dx. Now I should be able to do my replacements. 9 sine of 3x dx are replaced by 3 du. And then this thing is just 1 over the square roots of u. All right? That's the same as 3 times, this is u to the negative 1/2 power du. Anti-differentiate using the power rule, and that's going to become 2u to the 1/2 plus c, I believe. Let's see, that's u, yes, that's correct. All right, and at this point we want to plug back in what u is, so you're going to get 3 times, well, 3 times 2 is 6, so you really got 6 over here, and then you've got u, which is 9 minus cosine of 3x, the square roots of that, plus c. All right, let me check the answer. And the answer here is 6 times 9 minus cosine of the square root of 9 minus cosine of 3x plus c. Perfect. Let's go on to number 10. Number 10 says, find f prime of 0 given this nasty function. This nasty function I immediately notice is a quotient. So to take its derivative, I must use the quotient rule. Low, d high, minus high, d low over low, low. The trick is to write it out properly. So let me go ahead and do that, all right? Here's the function. Let's get the derivative written properly. F prime of x equals low sine of x plus tangent of 2x minus 4. D high is 3x squared minus high, which is x cubed minus 1. D low, which is going to be derivative sine of x is cosine of x, derivative tangent of 2x, that's another chain rule. Derivative tangent of x is secant squared x, so this is plus 2 secant squared x. That's important, right? Derivative tangent of 2x is secant squared of 2x times derivative, which is 2. Chain rule, so many times. Derivative minus 4 is 0, so that's not an issue. All over, what? The low, sine of x plus tangent of 2x minus 4 squared. Now, thankfully, we're asked to find f prime of 0. So this thing's going to have a lot of canceling going on, won't it? Thank God. Let's start over here. Sine of 0 is 0. What's tangent of 0? 0. Minus 4 times 3 times 0. So that's all going to go to 0. Minus, this is 0 minus 1, which is negative 1, times cosine of 0 is 1. Secant is like 1 over cosine. So cosine of 0 is 1. 1 over 1 is 1. So this is just 2. Okay, again, sine of, this is all going to be squared, right? Sine of 0 is 0. Tangent of 0 is 0. So you got minus 4. Okay, let's keep going here. This is all 0. This right here is 3 times positive 1. So that's 3. Denominator, you got negative 4 squared, which is 16. So the answer should be 3/16 to this problem. We'll get the answer key here for number 10. And in fact, it's 3/16, so we're good to go. All right. Number 11. It says, a ball is thrown downward with a velocity of 30 meters from the top of a building. Okay. So I always draw a picture and make sure I know what I'm doing here. Here's the top of a building. And this building is at 30 meters. And the ball is thrown downward with an initial velocity of, it's 220 meters tall. 220 meters tall, we're told. 220 meters tall, we're thrown down with an initial velocity, a velocity at time 0 of negative 30 meters per second. You say, why negative? Well, you can say it's thrown down at 30 meters per second, or that it's got a velocity of negative 30. By convention, that's positive, that's negative, right? All right, and we know acceleration due to gravity is 9.8 meters per second squared. We're supposed to develop velocity and position functions. All right, you know how to do this. We write down everything we know. We know that a of t is equal to 9.8. That's my acceleration function, because this is a gravity situation. We know our initial velocity is equal to negative 30, and we know that our initial position, I'm going to call it y of 0, because that's like a y-axis, right? That's what that basically is. Y of 0 equals 220 meters, our starting position. All right, a of t equals 9.8, therefore v of t, its antiderivative, is going to equal the antiderivative 9.8 dt, which is 9.8t plus c. How do I find what c is? I plug in 0, negative 30. And so I'll get negative 30 is equal to 9.8 times 0 plus c, implying that c is equal to negative 30, which is not surprising at all in this particular case. So v of t is equal to 9.8t minus 30. How am I going to get the position function now? Y of t. Anti-differentiate again. So you get 4.9t squared minus 30t. And then, once again, I can go through this pedantic process, but I can see, because I have 0 being plugged in, this is going to be 220. Good. I've got a velocity function and a position function, which is what I was asked to develop. Now, part B, asks me how long will the ball take to hit the ground? So you want to know the time the ball hits the ground. Well, when do you know the ball's on the ground? When the position of the ball is 0. Okay, when the position of the ball is 0, so just set the position function equal to 0 and solve. All right, there's no way that easily factors, so you're going to have to, how do you solve for the zeros of a quadratic function that's not pretty? Use the, what's this thing called? Quadratic formula. Negative b plus or minus b squared minus 4ac over 2a. Let's see if it's already written out here so I don't have to think it through. It is. Oh, this is t, of course, not x. So t is going to equal 30 plus or minus the square roots of 30 squared plus 4 times 4.9 times negative, so it's times 220 all over negative 9.8. Okay. And when we do that, what do we come up with? Well, we come up with this. This is exactly what we've got. But if you did get to use a calculator, which I didn't let you, you would come up with 4.306 seconds, and you'd come up with t equals negative 0.4285. This one you're supposed to chuck out. Like, how is the ball going to hit the ground before you throw it? If you're starting and throwing it at time 0, like back in negative time, no. So this is the only valid solution, and that's a thing. Okay. Good. Let's just check to make sure we have the right functions in here. Yeah, everything seems good. Number 12 then, and we are done. Number 12 says, find the following limit. So you just got to use just limits here, okay? This right here has got to be some sort of vertical asymptote situation. This is a vertical asymptote situation, and this is the limit definition of a derivative. So A and B are a class, and C is something totally different. All right, A, find the limit as x approaches 0 from the right of negative 1 over x. Well, you know what y equals 1 over x looks like. Negative, that function just inverts about the x-axis, so you wind up with this function. Okay, that's y equals negative 1 over x. Now I'm going to approach 0 from the right-hand side and see where my y values go. Where are they going to? Negative infinity. That's it. Part B says, what is the limit as x approaches 0 of 1 over x squared? You know what this thing looks like. This is the volcano function. Well, as a two-sided limit, as x approaches 0 from both directions, f of x approaches infinity. So negative infinity. Now, part C is totally different. This says the limit as h approaches 0 of sine of x plus h minus sine of x over h. You say, what am I looking at here? Some sort of crazy limit? If I just look at it as a limit, I'm going to plug in 0. And we get 0 over 0. It's an indeterminate form. Now I'm going to try to use L'Hopital's rule, which isn't going to get me anywhere. And at this point, you didn't even know anything called L'Hopital's rule, which still won't get you anywhere. So, what are you going to do? What are you going to do? You are going to realize that this is the limit of a difference quotient. Do you see it? This is sine of x plus h minus sine of x over x plus h minus x, which of course always turns into h. So you'd say, okay, that's the limit definition of the derivative. But derivative of what function? The derivative of this function, right? Isn't it the limit as h plus 0 of f of x plus h? So f is your original function. So this is telling you to take the derivative of sine. How do you write that? You can write it many ways. You go sine of x like this, prime. Or you write ddx of sine of x. If you want to take the derivative of sine of x, this is how you do it with the limit of a difference quotient. So now this is super easy. What's ddx of sine of x? Cosine of x. That's your answer. These kind of problems they love on the AP exam, by the way. Just do you understand the limit definition of the derivative? Thanks for hanging in there with me for 40 minutes. It was the only technology I had available to me today. Sorry about that. It's really slow upload too, but it is what it is. So enjoy. Goodbye. Happy weekend.